All right, so today we are finding trig values of special angles. So these are going to be quadrantal angles or 30, 60, 90, 45, 45, 90, something like that. We're finding exact values. There's no calculator involved here. Actually, this is not part of it. We're not going to find decimal approximations. We're just going to do everything by hand. Okay. So the first bunch we're going to use the unit circle for. So you're going to be able to use the unit circle to find exact trig values when the angles are quadrantal angles. So you should know what those are, like 0, 90, 180, 360, 270, etc. Okay, then you can rely on this. You can rely on this in the relationship that you know that, in a unit circle, sine is going to be, sine of an angle is the y-coordinate, cosine of an angle is the x-coordinate, and tangent is going to be the y-coordinate over the x-coordinate, because for these angles in a unit circle, this is called a unit circle because the radius is 1. Circles that aren't a unit circle, you have a different radius, there's different relationships, but here the radius is 1. So it is as simple as sine is y, cosine is x, and tangent is y divided by x. So let's see one example that uses the unit circle. So find the values of the 6 trig functions, so sine, cosine, tangent, cosecant, secant, and cotangent, for an angle in standard position measuring 180 degrees. So I'm going to draw a unit circle, a circle with a radius of 1. I'm going to draw the coordinates around. Actually, I don't need to draw the coordinates. I just need to draw the ones at the angle we're looking at, which is 180 degrees. So the coordinates of that point where the unit circle crosses at 180 is -1, 0. Okay, so first, let's find sine of 180. Well, sine of 180 is the y-coordinate of that point, and the y-coordinate of this point is 0. Okay, cosine of 180. Cosine is the x-coordinate at that point, and the x-coordinate at that point is -1. Then tangent, well, tangent is the y-coordinate divided by the x-coordinate, so that's 0 divided by -1, which is 0. So those are the first three, and then we have the reciprocal functions. Cosecant of 180 would be the reciprocal of what the sine would be, because sine and cosecant are reciprocals. So the reciprocal of 0, well, you can't divide by 0, so that's undefined. Secant of 180, that would be the reciprocal of cosine of 180, and the reciprocal of -1 is -1. And then cotan of 180 is the reciprocal of tangent of 180. Well, tangent of 180 is 0. Again, if you flip over 0, 0 would be in the bottom. Can't divide by 0, undefined. Okay, so you can use the unit circle along with its coordinate point for anything, whether it's in radians or degrees, if it is quadrantal. Okay, so now let's look at some things that are not quadrantal, and therefore we cannot rely on the unit circle. So it says to find other trigonometric functions, we use the relationships of a 30, 60, 90 triangle or a 45, 45, 90 triangle. So from geometry, I know in geometry they have you memorize these relationships. And again, if you were going to put this on a coordinate point, the radius here is 1. So we have a 1. But I'm going to show you in a minute. We'll do these with the triangles, but I don't like memorizing triangles, having to draw the triangles. I do have a special way of doing this in a minute, which I will show you. Okay, so first of all, we'll do it without my special trick. So find sine of 30 degrees, cosine of 30 degrees, and tangent of 30 degrees, because ultimately, you'd like to be able to do these fairly quickly. It's like memorizing your multiplication facts. You just want to be able to do it quickly. Stopping and drawing a triangle isn't really me doing it quickly. So I've got an angle of 30 degrees. So opposite of a 30-degree angle in a 30, 60, 90 triangle is a side of 1. Opposite the 90-degree angle is a side of 2. And then opposite the 60-degree angle is root 3. Okay, so we can still use what we used in the first example, except for the radius now is not 1. The radius is 2. Okay, so now our relationship has to involve not just the x and the y coordinates, but also the radius as well. So sine, now you didn't see this in the first example because the radius was 1 and y divided by 1 was y, but sine of 30 is really the y coordinate divided by the radius, and the y coordinate, or y, yeah, over here is 1 divided by the radius of 2. So sine of 30 is a half. Cosine of 30, well, cosine is x divided by r, again, when r is not 1. So x is root 3, r is 2, that's root 3 over 2. Lastly, we have tangent. Well, tangent is still y divided by x, like it was in the first example. So here y is 1, x is root 3. So 1 over root 3, not how we're going to leave our answer because that's not rationalized. Rationalize the denominator, multiply by root 3 over root 3, and you get root 3 over 3 for tangent. Okay, but again, I'd like for you to be able to do these quickly. That's the point. Okay, so we're going to have a hand trick for that. I love the hand trick. Hopefully you will as well. So let me just draw you, and then I'll show it to you here, a hand. Okay, so it says for angles not in the first quadrant, you're going to use the angle's reference angle. Because a reference angle will always be between 0 and 90, and we're going to draw our hand as 0 and 90. So you're always going to use your left hand. So let's see how terrible I can draw a hand here. There's my thumb, and then there's the rest of my fingers. Okay, so I'll show you in a minute when I show you my actual hand, but you're looking at your hand, and you can make the first quadrant out of your fingers. So this would be 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, it's like if you, I don't know if I can actually do this or not, but let's try, give it a shot. If you took, look at that. If you took your hand and angled it like it was the first quadrant. So here, kind of seeing the first quadrant. And then you can see, halfway in between is 45, and that's why we use the hand. I don't hold it at that angle to see the first quadrant, but you can. Okay, so we're going to use this hand trick to find sine, cosine, and tangent. And then if we ever wanted any of the reciprocal functions, we would find these and flip them over. So sine is going to be the square root of the right side of your hand divided by 2. Cosine is the square root of your left side of your hand divided by 2. And tangent is the square root of the right side of your hand divided by the square root of the left side of your hand. So you're probably looking at your hand thinking there is no left and rights. So again, this is what I'm going to show you on my hand in a second, because I can't show you my hand and the paper. So first of all, let me give you, actually, let's use the previous example first. So let's see how it ties in with sine of 30, cosine of 30, and tan of 30. So let me flip over to my camera. Okay, get a good angle of my hand. Let's see. We're trying here. Okay, if only I could zoom out, but I can't. All right, so here's my hand. Again, if you hold it like a first quadrant, like a 90-degree angle, this is 0, 30, 45, 60, and 90. I just use my hand, flat the way it is. but it's really because that can represent the first quadrant. Okay, so all this left-right business. So we're working, again, with that example we just did. So I'm working with 30 degrees. Hold on, let me just. So 30 degrees, I put it down. Okay, so now the angle I'm working with gets put down. Now I'm separating into the left side, these 3 fingers of the left, and the right side. I have 1 finger on the right. So it's that angle you're working with that you put it down and separates your hand into left and right. So sine is the square root of the fingers you have left on the right side, divide by 2. This would be the square root of 1, divide by 2, sine of 30 is a half. Okay. Cosine I'd written down was the square root of the left, divide by 2. Well, I have 3 fingers over here, the square root of 3, divide by 2. And then I had written down that the tangent of an angle is a square root of the fingers on the right divided by the square root of the fingers on the left. That would be root 1 divided by root 3, which rationalized is root 3 over 3. Okay, yeah, we'll get this down. So let's try with another angle. Now this one's in radians. And if you have to, you can write radians on your hand. I just write degrees, and I know what they are in terms of radians. But 0 degrees is 0 radians. 30 is pi over 6. 45 is pi over 4. 60 is pi over 3. And 90 is pi over 2. You can literally write these angles on your fingers if that's helpful. Okay, so this example. Okay, so we're working in radians. And this is not a first quadrant angle. So if you're not dealing with a first quadrant angle, you're going to want to find this angle's reference angle. Because then the reference angle will be something on the hand trick. So 5 pi over 6 is an angle in quadrant 2. I'm going to draw all students take calculus. Okay. Students take calculus. This is a mnemonic for remembering what's positive where. So in first quadrant, all are positive. In second quadrant, S stands for sine. Sine is positive. The others would be negative. Take is tangent. Only tangent's positive. And quadrant 4 for calculus, cosine is positive. Okay, there's a lot to think about here. It's not just the hand trick. All right, so let's find this reference angle. So the reference angle is the angle it makes with pi. So the difference between pi and 5 pi over 6 is pi over 6. And we're finding cosine of that in the second quadrant. Cosine in the second quadrant is going to be negative because only sine is positive. So now we're going to go to the hand trick. Okay, pi over 6. I wish there's a better way than flipping back and forth. So pi over 6 is the same as 30 degrees. Okay, cosine is the square root of the fingers on the left, divide by 2. I have 3 fingers on my left. That's going to be root 3 over 2. And it's negative. Okay, we're going to try some more. I got some more for you in radians. Okay, oops. All right, negative 8 pi over 3. Well, first of all, that's negative. See, so there isn't just the hand trick here. There's all the other stuff we've been doing with coterminal angles, reference angles, what quadrant things are positive in, all of the things. So first of all, let me get this to a point where it's positive. So I add 2 pi, still not positive. I add 2 pi again. Now I'm positive. So 4 pi over 3, well, that's more than pi, but less than 1.5 pi. So 4 pi over 3 is in quadrant 3. Its reference angle is the difference it makes with the x-axis, which is pi. So 4 pi over 3 minus pi, or 3 pi over 3, is pi over 3. So we're dealing with a reference angle of pi over 3. So I'm going to find tangent pi over 3. All students take calculus. We're in quadrant 3. Tangent is positive. So positive pi over 3. Okay, so back to the hand. Pi over 3. I don't have my radians on here, but I know that's the same as 60 degrees. Tangent is the square root of the fingers on the right divided by the square root of the fingers on the left. I have 3 on the right. I have 1 on the left. That is root 3 over root 1, which is root 3. Okay, we'll get this. I know it's not easy. One more. Secant. Now, I told you there's no hand trick for reciprocal functions, so we're going to first use cosine. So this is negative, so let me add 2 pi. Okay, its coterminal angle is negative 5 pi over 4. That's still negative. I'm going to add another 2 pi. Okay, now I'm within 0 to 2 pi. Always the goal, get within 0 to 2 pi. I am in quadrant 2, because 3 pi over 4 is bigger than a half pi, but less than 1 pi. Somewhere in between here and here. So it's, students take calculus, we're in the second quadrant. We're looking for its reference angle. So the difference it makes with pi minus 3 pi over 4 is pi over 4 for our reference angle. And I told you there's no hand trick for secant, so first we're going to find its reciprocal function of cosine. And sine is positive in quadrant 2, which means cosine is negative. Okay, to our hand. Go. All right, pi over 4 is the same as 45. We're doing cosine. Cosine is the square root of the fingers on the left. Divide by 2. I have 2 fingers over here. So that's root 2 over 2. And it's negative. So now to find secant of that, I mean, ultimately it's secant of this. So if I flip over, take the reciprocal of what cosine was, and then rationalize, can't leave a radical in the denominator, I get negative root 2. Okay, so that's some examples of exact trig values. So again, unit circle when it's quadrantal, and hand trick, I guess, or you could memorize 30, 60, 90, 45, 45, 90 triangles if you want, but yeah, that's how I do it, hand trick.